Hi everyone, this is the example number 3 video for the camera tutorial series. In this example we'll be measuring this plastic part, and the key things in this tutorial are scanning a curve around a feature and then constructing features from that scan data, and also measuring the teeth on the gear. So you can see here this is a very small tooth profile, very difficult to get in with even the smallest contact probes. This is no problem for the camera, so we'll go ahead and do a scan of this. So let's go. So just like previous exercises, let's make sure we have the image tools set up correctly. We're going to focus primarily on the gear teeth profile here. So again, we get somewhere near with the joystick. Just make sure your axis is unlocked so you can move it by hand to get it close. Then use autofocus. Let the software move up and down to get the perfect edge, the perfect focus. There we go. Again, lock the axis, and we are now ready to get some measurements. So this is a pretty good edge as it is. Again, we can try using the UV light to get an even better image. You know, you have to work it out yourself whether you think it's a better image or not. I think for this, let's just check the outside edge. I think we should be good. We don't need the UV light, so we're going to go ahead with just the standard setup. So to get this referenced up initially, I am just going to use the outside edge. This is more for a tutorial more than anything else, but just to show you, if I turn this to curve, start on the edge, this is the scanning window, scan in this direction and stop here. You watch the camera step around now, and it'll keep going around the edge. Let's move this down here now so you can see what it's doing. And it's automatically following that edge around, and it should continue and loop all the way back until it gets to the start. Now we're using the camera for this. You can also use the touch probe if required, but the main goal of this exercise is to show you the construction of features from curve data. So as you can probably imagine already, we will construct a circle from this curve feature, and that will be our reference. And you'll see it's taking thousands of data points, which would be very difficult to do with a touch probe. It would take a long time. It would only compare to a SP25. So as soon as we see the stop sign finish, there we go, it's done. So this is just point cloud data for now, but we can go circle construct, highlight a box around the entire curve like this, set this as a reference, and that is now going to construct a circle from that data, which we can then dimension just like anything else. I can change that to diameter. There we go. And I'm pretty sure it's an 84 diameter circle. So that's the first part of the exercise. The next part of the exercise is the curve scan of the teeth. Process is exactly the same. So curve, we go 1, 2, 3 and 4. Again, start on the edge as the first click. You then set the scanning window. You then click on the direction you want to scan in, and then finally you get the crosshairs to tell it where you want to end the scan. So ideally somewhere very close to where you started, and that will scan the entire profile. So it's automatically moving around just like it did for the edge. And there we go, we have that complete. So you can see here, again, this is just point cloud data. We need to be able to compare this to something. So this is where we are going to compare to DXF. So if we go to inspection, DXF, import DXF. So we will open up the DXF, import as a curve profile, and it's very important you get your units right. So depending on what software you use to export this, I know that the one I use needs to be in centimeters. Whichever plane you're using, so we're using XY here. Default tolerance, this can be altered later on if needs be, and you can choose to round corners or not round corners. So I'll turn this off because that will be important. I just want to use the DXF as is. We say finish, and the idea is it now overlays the DXF on top of your measured data. Now the DXF can be manipulated via the mouse wheel. So if you press the mouse wheel in and move the mouse, we can move it around as so. We can also manipulate it via these icons in the toolbar. So this moves it up and down, left and right, and these two rotate it. What I like to do is if you just offer the DXF up somewhere near, you can then press play and that will run the optimization. Now it's important to note you can optimize to the nominal, the tolerance that's allowed, or to specific features. So in this particular case, if we had within the DXF the OD, we could use that OD to basically optimize and fix the XY position to the center circle. In this particular component, we aren't bothered about doing any of that. We'll just use the nominal and we'll press play. And the software will run through iterations to try and best fit the DXF to the scan data. And then from that, it will give us a profile size. So you can see already that's now fully complete. And if we zoom in on the DXF profile, anything that's outside of the profile shows as red. Anything inside the profile shows as green. And we can also dimension that profile as so. So it's very useful. We don't have to measure every single individual tooth and size. We do a profile size, and you can also get a profile printout of that, even by looking at the curve data itself. So we can zoom in, modify the scale, modify the tolerances, whatever is required. So that is example number 3 complete.